All right, so let's talk about different types of bonding. So I can either have what are called sigma or pi bonding, okay? And this might sound like it's really complicated and complex, but really we're just talking about the difference between a single bond and a double bond, okay? So let's first talk about the sigma. So if I'm talking about sigma, sigma is this little Greek letter like this. Almost looks like it's a little 6 that fell over, got tired and fell forward. So this is the sigma. So sigma is when my atomic orbitals are going to overlap, but in a single location, in only one spot. And that overlap is going to be directly between the nuclei. So let's look here. So here's a p orbital, here's a p orbital. If these two p orbitals are going to overlap, this overlap right here, it's in one spot, and it's between these two nuclei. So imagine this is a molecule, an element, this is an element. It's coming together to make a bond. And so where these orbitals overlap, right here, it's in one location between the two nuclei. So this is what we call a sigma bond. It's overlapping right here, end to end, and it's going to form my sigma bond. Okay? Let's compare that to pi bonding. So pi bonding, the symbol here is the Greek pi. Okay? But the difference here is that the overlap in my atomic orbitals is in two locations, where the other one was in one. And the two locations is going to be above and below the plane. Right? Above and below the plane. So here, when my two p orbitals come together, the sides, not the ends, but the sides of these orbitals are going to hit each other and overlap. So this is called a side-to-side overlap, and it's not between. The overlap is above and below where my nuclei are, and it's in two spots. Okay, so if it's in two spots above and below, it's called a pi bond. So let's compare. Sigma bond, one spot. Pi bond, two spots. Sigma bond is end to end. So it's end to end of those orbitals. Pi bond is side to side of those. So how do I know if I draw the Lewis structure if I'm doing a sigma or if I'm doing a pi bond? The very first bond between any two atoms is always going to be a sigma. So the very, very first one, see, here's my carbon, here's my oxygen, they're going to come together to make a bond. That very, very first bond is going to be a sigma bond. So the first bond is always a sigma bond. If they do another bond, say they do make a double bond or something like that, the next bond between those same two atoms is going to be a pi bond. So the first one is sigma, the second is pi. So here's the sigma bond. If it's doing another one, this would be my pi bond. So we have one sigma bond, one pi bond, and that is what makes my double bond. Okay? So now, sometimes you would think it's like, oh, well, it's 3. It's not 3, okay? Because when you make one pi bond, it just happens in two locations. So it's two locations for that one pi bond. So when we're counting how many bonds, don't count 1, 2, 3. Count one sigma, one pi, two bonds. That's what makes a double bond. So a double bond has a sigma and has a pi bond because of the way it's going to overlap. Okay? So since double and triple bonds are placed along an already existing bond axis, they don't create a new region of electrons. So this is why whenever I'm counting my electron groups, it doesn't matter if it's a single bond or a double bond when I count. I just count attachments. So remember if it was, something like this, we would saw this is one electron group, this is one electron group. The reason this is only one electron group is because it's not creating a new region. All it's doing is adding to this region that was already created. So double bonds and triple bonds are along an already existing bond axis, that sigma bond. They don't create any new regions around the central atom. This is why it doesn't matter if it's a double bond or not whenever we're looking at the shape and the hybridization. So they, therefore, do not affect hybridization or shape. So this is why we count a double bond or even a triple bond as one electron group, just like if it were a single bond, because it's not adding any new electron regions. All right, so let's talk about, well, how am I going to be like asked maybe a problem or something about sigma and pi bonding? So now that we kind of know how it's happening, I can actually go through and look at a molecule and be able to determine how many sigma bonds are there and how many pi bonds are there, just looking at the type of bonding that's occurring. Because a single bond is a sigma, a double bond is one sigma, one pi bond. So I'm going to use that to answer the next question.